at this histogram question. A class of 30 students kicked a football at a penalty match. The distance kicked by each student was measured to the nearest meter. The results are shown below. So we have to copy and complete the table. All right. So we have distance in meters, 10 to 19, 20 to 29, 30 to 39. So if we follow any pattern, this is 40 to 49, 50 to 59. All right. What is this missing number? The total number is 30. So if we have 8 plus 2 is 10, plus 3 is 13, plus 2 is 15, right? 15 from 30. Here it's supposed to be 15 as well. Copy and complete the table, done right there. State the lower boundary for the class interval 30 to 39. So lower boundary is just 0.5 off of the lower class limit, right? So 30 minus 0.5 is 29.5. Nice. So we have here part C, using a scale of 1 centimeter on the x-axis to represent 5 meters and 1 centimeter on the y-axis to represent 1 student. Let's draw your histogram to illustrate the information. So let's jump on that one time. So this is a graph here. Let me draw. Since we do not have negative numbers, we just use the border of the graph. Right. Let me neaten up that here. So they said 1 cm on the x-axis to represent 5 meters. So this is 0, 5, 10, 15. All right. So when I look at my my table here, the highest number is 59. So I know if I use my x, because distance will be dealing with the x, once I have up to 59 are good. So when I look at my graph, I have 70 here on my x-axis. So I can just say distance meters. I good right there. The y, 1 centimeter to represent 1 student on the y-axis. The largest number is 15. So once I have 15, so if I go up to 15 itself, I good. But I'll go up to like 20. And this represents student. Right? As I said, you could stop at 15. It'll be good. All right, so we have to draw a histogram. Now, the histogram, when we draw the histogram, we're using the boundaries. We're not using the limits, lower limits and the upper limits. You'll be wrong. We have to use the boundaries. So the boundaries, this is 9.5, 19.5, 19.5, 29.5. Right, if you notice, to get the lower boundary is 10 minus 0.5. So all you have to do is minus 0.5 from all of these numbers to get the lower boundaries, and to get the upper boundaries, you add 0.5 to these numbers here, right? You'll see that we have the same number here and here, right? Here, and here, and then here, and here, and then, here and here. It just goes to show that a histogram is joint, right? So that is why you see the same number for the boundaries, right? This upper boundary here will be the lower boundary for the next interval. All right, so let's draw it now. Using the boundaries, 9.5 to 19.5, and that's going up to 2. Nine 9.5 to 19.5, and that's going up to 2. All right. If you notice, you see now blurred effect, because this is this 5, 6, 7, 8, 9, this 10. 9.5 is in the middle, right? This is 15, 16, 17, 18, 19, 20. 19.5 is in the middle, right? So that's why you get a kind of blurred effect. The next one is 19.5 to 29.5, and I'm going up to 8. All right. Next one is 29.5 to 39.5. That going up to 15. Just deal with this a little better than that. All right. 39.5 to 49.5, and now going up to 3. So since we have this already, this end drawn, 49.5, we'll subtract that. And 49.5 to 59.5, and that going up to 2. 59.5. That's going up to 2. Right? So we have everything. We have our axes labeled, right? If you remember, a histogram isn't, you have to use the boundaries. Let me fix this here because I find this looks a little, right. We're using the boundaries. When you use the boundaries, you'll get a blade effect. The histogram is joint. We have to use the boundaries. If we don't use the boundaries, the histogram will be, each rectangular bar will be separated, and you'll be wrong, right? Because it's not a bar chart. All right, so that's it for drawing this histogram.